attention, please. We're going to move on to the other side of your worksheet. We're going to finish 2.5 now. You have 4 questions after this one, so just keep your responders. Explain the function of a catalyst. That is side conversation when you go back to 0, okay? So we can move through it. Describe how enzymes work in your body. It says you, but your body. All right. So what is a catalyst? They decrease the activation energy. 2, they increase the rate of the chemical reaction, which basically means that they speed it up, because some people don't know what that means. So what is a catalyst? A catalyst is a substance that helps speed up chemical reactions. So the yeast in that reaction earlier, the yeast acted like a catalyst. It wasn't actually part of the experiment. It just helped hydrogen peroxide become oxygen gas and water faster. It actually wasn't used up at all. Okay, that's why it was all still there after the reaction. Now, because if you remember, what is the activation energy? Anybody? What is activation energy? Anna?
The amount of energy needed to do a chemical reaction to take place.
Exactly. So remember, it's the big hill and it's the top of the hill. Now, a catalyst or an enzyme, because they're the same thing, has the ability to make this reaction happen easier because it helps the substrates, the reactants, find each other easier. So by doing that, they start at the same place. We're not changing what the reaction is going to do. The only thing that the enzyme or the catalyst does is it changes the amount of energy needed. So instead of being the orange high hill needing all that energy, you now only need this amount of energy to do the same exact reaction. And that is what a catalyst does. It lowers the amount of energy needed so that this reaction can happen faster. You are expected to know this chart on your test. So big mistakes that sometimes you guys do is that this is the chart and you think that the enzyme chart goes like this. That's not right. It doesn't change the bond energy of what you start with, and it can't change what you end with. All an enzyme does is help this reaction take place. Remember the yeast? The yeast was there at the beginning and it's there at the end. It is not consumed in the reaction. It is not used up in the reaction. So all it does, this would be incorrect. They must start at the same place. All it does is it makes the hill lower. The amount of energy needed is lower. So you are expected to be able to know what this is showing you if you were to see that graph, or you should be able to identify it. That's why here it says activation energy. You need to know the definition and the graph. Okay? All right, so what is an enzyme? An enzyme is everything a catalyst is, except it's a biological catalyst. So that's all you really need to add in that box. What is an enzyme? It's a biological catalyst. So everything on the last slide is an enzyme as well. It increases the reaction rate. It decreases the amount of energy needed. It's a catalyst. It's the same thing, except when it's found in a living thing, we call it an enzyme. Now, enzymes are in the family of proteins, which are your macromolecules you just looked at. It is a protein, which will be next. Here are some common, I don't know if it was this class, but someone had talked about how in middle school your teacher had you chew on a bunch of crackers, or she did, or he did, and then they took out the saltine crackers and they took it out of their mouth, left it on the counter, and let the amylase continue to break it down. Was it in this class?
No.
So what happens is, I don't do it because it's disgusting, but what's happening is that amylase, which is an enzyme, it's in your saliva, your spit, and what it does is it helps break down sugars into simpler ones. So once you put enough spit on that cracker that you emulsified in your mouth, You could leave it on the counter and the amylase would continue, the enzyme would continue to eat it up. That's not. Not very long, like a clock. So, there are a lot of different enzymes in your body. Some of us are not born with all our enzymes. For example, people who are lactose intolerant tend to not have the enzyme lactase. Lactase is the enzyme you need to break down lactose, which is the sugar found in milk. So there's a lot of different enzymes that work in your body to help you survive. All right, enzyme structure and function, that box, there's a lot to write in there. It keeps you alive.
Yeah.
All right, enzyme structure. Enzymes, first and foremost, they are protein. Second, they're held together by hydrogen bonds. Now, every enzyme is specific. For example, lactase, which breaks down lactose. That's all it does. It can't do multiple jobs. Amylase breaks down complex sugars. So they're very specific on what reactants they can help. Yeah, go ahead, Pete.
But like for people that like to only like for like some dairy products don't affect.
So what probably, when it comes to lactose intolerant, it's not that you don't make the lactase at all, you don't make a lot of it. So something that has a lot of lactose in it is going to bother you more and your body can't keep up with it as much as if it doesn't have as much lactose. Your body can kind of keep up with it and so it doesn't bother you.
Yeah, I'm lactose and I can stomach like ice cream with my stomach without like cheese.
And there's definitely a big difference between the sugar amount in those two foods.
Yeah, that's
Yeah. They are very sensitive to certain conditions. So they are designed to work at a certain pH. So the enzymes in your stomach have been designed to work at a pH of 2. That's where they like to be. So it's not all enzymes work better at a pH of 7. They can work at whatever pH they've been designed to work at. However, if they've been designed to work in your stomach at a pH of 2, which is very, acidic, they're not going to be able to work in an environment that's basic. They will what is called denature. Denature is an important vocabulary word, and it means that once they get into the wrong environment, they unfold, because they're proteins, they're folded, they unfold and they can't work anymore. They're also sensitive to temperature change. What is too high of a temperature for your body?
20 million degrees Celsius.
For your body, like inside, internal temperature. We can't go nowhere near that, huh?
100.
100 would be a low-grade fever. Your mom wouldn't take you to the doctor for 100.
105.
102 is a real fever, so there's something wrong with you.
105.
105 to 106, you need to head to the hospital. So the enzymes in your body are sensitive beginning at 106 to 108. 106, they're going to start to denature, which means the enzymes in your body are going to start not to work at 106 degrees Fahrenheit. And you need those millions of enzymes to help your body do what it does. Your body could not do those reactions fast enough to keep you alive without enzymes. Enzymes help speed up your chemical reactions. So if your fever gets too high, denaturation is going to happen and you're not going to be able to survive. So that's why it's so dangerous to go above 106. Well, they're sweating because their body's trying to cool itself down. Go ahead and get these last 3 boxes. That goes in the bottom. No, just write them in those 3 boxes. This is the substrate box, and that's the lock and key box. So you don't have to draw the picture, it's just the writing. So step 1, substrate binds to an enzyme at certain places called an active site. So where they attach to is called an active site. So 2 and 3. The enzyme brings the substrates together and weakens their bonds. So in the reaction we just did today, the yeast, what it does is it grabs onto hydrogen peroxide, attacks it, and then helps hydrogen peroxide break into 2. Helps it break, helps it break, helps it break. So enzymes can help things break down or form. Depends what you're working with. Substrate is another name for reactants. Once the reaction is done, the enzyme just goes on its happy, merrily way. You do not use up enzymes in a reaction. They are not considered a reactant or a product. They're just an enzyme. 2 and 3 in the other box. This one goes in the substrate box. And I'm just making that up. This makes it neater. Good? I'll give you a minute.
Hi, my name is Henry Goddard, and this is a presentation on how enzymes work. An enzyme is a living protein inside our bodies that helps us speed up reactions. It does this by lowering the activation energy of the reaction. This is Milo. Milo is an enzyme. This is Milo's activation site. This is where a substrate will bind on and cause a catalyzation. However, only a specific type of molecule will fit this site. Oh, here comes one now. This is Ernest. When he sits on Milo, he will split into 2 separate molecules. And as you can see now, we have Pete and Bertrand, who are pushed out of the enzyme. Milo, as you can plainly see, is an enzyme designed to break apart substrates. Remember, Milo didn't start this chemical reaction. It would happen regardless of whether he was here or not. He just speeds up the reaction.
Bye.
Now, let's say we have another enzyme, Larry the enzyme. Larry will attract 2 separate substrates. Here they are, Sylvester and Orlando. Like Milo, Larry seats the 2 substrates in his active site. However, unlike Milo, Larry fuses the 2 together, and now pushes 1 single molecule out. Steve.
Steve.
This animation was brought to you by
That's fine.